Okay, our final talk is going to be given by Dr. Michael Schwartz, and his talk is entitled The Future of Transportation, AVs, Tolls, Carpools, and Remote Driving. Let me say a few words of introduction to Michael. Michael is a corporate vice president and chief economist at Microsoft. He runs an office of economists and data scientists, and they're engaging in primarily three areas at Microsoft. The first is demand forecasting to optimize capacity, planning, supply chain management, and to identify top trends. The second is product pricing and discounting. And the third is market design to optimize the effectiveness of marketplaces. So what Michael does is to drive key topics and themes that need cross-company economics representation. Before joining Microsoft, Michael worked at Google, where he was most recently chief economist for Google Cloud. And prior to that, he led the team that built the carpooling marketplace Waze Carpool, where he subsequently became chief scientist for Waze. Before Google, Schwartz was the head of economics research of the economics research unit at Yahoo, where he worked on designing ad marketplaces. And I'll add that Michael, together with Michael Ostrovsky at Stanford, a few years ago published the paper Carpooling and the Economics of Self-Driving Cars, which is a really fascinating paper focusing on three technologies: autonomous driving technology, time-sensitive tolls that can vary for each road segment, and carpooling technology, which matches cars with passengers. And they propose a framework, both a modeling framework based on game theory, and then a analysis to understand how to achieve socially efficient outcomes. So it's a great pleasure to, and as I was saying this, I remember, Michael, you're not using slides. So it's a great pleasure to introduce you and to have you speak and participate in this workshop.
So Claire, thank you very much for a very kind introduction, and thank you for workshop organizers. I think it's a wonderful, wonderful workshop. So I will not be using slides. I think that the future of transportation is going to be very different from the present. And I thought for a very short talk, let me try to do something very different too. I will go without slides, and we'll see how it will go. So first, let me talk a little bit about the paper that Claire already mentioned. And the paper is very technical. It actually proposes an algorithm for how to compute tolls and carpool prices. And I'm not good. It's not possible to describe those algorithms in 15 minutes, but the paper is on the web, so whoever is interested can easily find it. But I want to kind of take a couple of steps back and think about, so what's the future of transportation is going to be like in light of all the new technologies that are coming online. And obviously, we are all thinking about self-driving technology. And we know it will change how traffic flows. We know that it might possibly increase the throughput of the roads. And I think to some extent, Alex's talk this morning alludes to that, and so is Carl's talk. But nevertheless, there's a limit to how much roads, how much cars could, how high throughput could go. And I don't think it could be that much higher than it is today. But what will be much higher is the amount of cars on the road, the amount of traffic, because as people can read and play and work on the way to work, they will be much more willing to be stuck in traffic because it's just less painful to be stuck in traffic when you are being productive or enjoying your day. And they will be much more willing to have longer commute, longer miles, longer time. And that, of course, means that at some point, there would be a lot more traffic congestion unless something is done. And by the way, it's very easy to write down a very simple economic model, just straight out of Vickery's classic paper, same model, and see what would happen in that model if self-driving cars are introduced and driving becomes, and being stuck in traffic becomes less costly. And what happens is that you can essentially dissipate all the gains from self-driving technology simply because there's more traffic. It could be that bad. We certainly don't want that to happen. So what could be done and what will be done? So I think that in the future, as self-driving technology will become available, there will be only two ways to avoid incredible traffic and incredible gridlock on the roads. And one is we introduce time-sensitive tolls. So kind of the disutility of being in traffic goes down because of self-driving technology, but during rush hour, you have high tolls, and that deters people from either very long commutes or commute during rush hour. So that's one possible solution, and I expect that that's coming. And with satellite tolls, it will become feasible to have ubiquitous tolling without costly physical infrastructure. But there's a problem with ubiquitous tolling. Right now, all of us are in some sense equal in front of traffic. And people like egalitarian element of that. I mean, traffic is terrible, but at least we are all equal before it. But of course, with tolls, we are no longer equal. People who are wealthier have right now, you pay with your time for the privilege to use the road as you're stuck in traffic. But with tolls, you pay with money, and that means that people who have a lot of money are in some sense in privileged position, and that would really hurt people who are in the low half of the income distribution. So what else could be done? Well, I think that carpooling will become really much easier to do and much more available and much more attractive in self-driving era. And once you have tolls, there's this extra incentive to carpool, because if there are 3 people in the car, well, they split the toll 3 ways. So I anticipate that the future of transportation will consist of not just self-driving cars, but the self-driving cars will bring in ubiquitous tolls, and will also bring in carpooling that will become the dominant form of public transportation. And that argument is kind of fleshed out in the paper with Ostrovsky that Clara mentioned when she introduced me. So I would like to mention, so this is one prediction. The future holds self-driving cars, ubiquitous tolls, and carpool, and lots of carpool. So let me make another prediction. So right now, self-driving cars are just not safe enough to be operated without a human driver, a human backup. So one thing that I anticipate is that it might take a while for self-driving cars to become safe enough that they can really safely operate on the road without a human driver. So, for example, if you look at sort of the current safety of human drivers, we humans are extremely good drivers. We have 1 fatality per something order of magnitude 100, I think it's 100 million miles, something like that. Well, maybe I added a 0, but basically you will have to drive for a very long time before you know that your car is safe and that the self-driving car is safe enough. So I think that it's likely that we will see remote backup drivers. And of course, you can say, hey, remote backup drivers don't really help because, well, you have a driver in the car versus you have a driver remotely. Why would you want to do it? It's more expensive. But I think remote driving is going to be a big thing. There are a few companies in this space, and I think those companies are likely to do well. And I think remote driving, remote backup drivers are going to be a really big part of the future. With 5G technology, we have under 30 milliseconds latency, so we can quite plausibly have very, very low um, uh, latency and hence kind of very high quality remote backup. And I think that the reason that remote driving is enabled by 5G technology, and I think combined with self-driving technology, those cars with self-driving technology plus a remote driver will be extremely safe. Because if there's a glitch in the network for a second, self-driving technology takes over. Most of the time, the car is self-driving. Whenever there is a problem with self-driving, the remote driver takes over. So it will be very, very safe technology. And I think it will be extremely, extremely important in the future. And there are two reasons why it will be important. One reason is obvious and one is not. So let me start with an obvious reason. Self-driving technology may be safe enough on a highway when you go on a straight line, but maybe it has problems with particularly challenging exits or entrances to highways. So you can imagine remote drivers just taking over only during those spots where we know self-driving technology doesn't work well enough. So that's kind of an obvious economic argument. There's another argument that I think is possibly much more important or more important and maybe a little bit less obvious. And that is for a lot of people, ability to turn your car. So obviously with remote driving, you will have to pay per hour or per minute of that remote driving because basically there's a human being on the other end who is operating your car. So I think that even with very high hourly cost of remote driving, it could still create enormous economic value. Because I think for many drivers, ability to put the car in fully self-driving mode could be extremely, extremely high value. So for example, imagine a person going to work, then planning to go to a restaurant with the friends, and then planning to drive home. So, well, maybe that person is planning to have a few drinks. So, well, he couldn't be driving at all if he couldn't be driving even to work if he plans to have drinks after work later on. So basically, we create this value for this person because maybe he uses that remote driver capability only for 20 minutes out of the 2 hours that he spends driving during the entire day. Or another very important use case is parking, right? You came where you needed to go, you don't mind driving, but then you pay top dollar to a remote driver to drive your car half a mile to the nearest parking lot. So again, very high value applications. So I anticipate that in the near future we'll see lots of that, and that's probably how self-driving cars will enter the market. So thank you.
Thank you, Michael.